Hello, my friends. Thank you very much for subscribing to our channel. Two real numbers, x and y, fulfill the following two equations. Can you find them? Why not give a try, and we will come back soon. Although the second equation is a little complicated, it is still feasible to do a step-by-step calculation. Referring to the first equation, one can use x to represent y, and bring it into the second equation. Then the equation has only one variable, that is x. Then one can iterate the operations of squaring, transposition, and combining like terms, to find x. This is not impossible, but really sophisticated. In fact, we can simplify the problem by using a small trick. Before implementing this trick, let's first show how to look for it. The second equation is in fact an expression for y, but there is also another y on its right side. Let's see what happens if we bring this expression for y into the y on the right side. The result is an equation with exactly the same structure as the original one, but with more hierarchical levels, that is, a more complex equation. That is to say, keeping the original structure, say, somehow self-similarity, unchanged, a more complex equation can be obtained from a relatively simpler one. So, the question is, does it work if we do it the other way around? Namely, can a relatively simpler equation be derived from a more complex one? If so, we will have a way to simplify the original equation, and then further simplify it, ideally to reach the simplest one, where y equals x plus the square root of y. How to prove if we can do it? There is actually more than one way. For a student from 9th grade though, the easiest way to understand is probably the proof by contradiction. Before implementing the proof by contradiction, let's first determine the range of values on both sides of the target. Because they have both appeared as radicands in the original equation, neither of them can be negative. This is good, because in this case we can safely do the rooting operation, and the direction of the inequality will not change while they are rooted. Now let's start the proof of contradiction. Since the target is that y is equal to x plus the square root of y, we then assume that y is not equal to x plus square root of y. There are two possibilities then. One is that y is smaller than x plus the square root of y. We root both sides of the inequality, the direction of the inequality remains the same. And if we add x at the same time, the direction of the inequality remains the same. Now, the left side of the inequality just becomes x plus the square root of y, which is certainly bigger than y. By iterating the same operation, it can be found that the value becomes larger and larger as long as we root them followed by adding an x, until the rightmost expression of the inequality becomes the same as the one in the original equation. We prove that it contradicts the original equation. So y cannot be smaller than x plus the square root of y. In the other case, if y is larger than x plus the square root of y, in the same way, we can prove that, as the expression becomes more and more complex, its value becomes smaller and smaller. Again, it is contradictory to the original equation. Therefore, y cannot be larger than x plus square root of y either. So, y has to be equal to x plus the square root of y. That is, this more complex equation and this simpler one can be derived from each other, so they are equivalent. As a result, we can replace the more complex equation with this simpler one, so as to simplify the question. Now, referring to the first equation, we can use y to represent x, and bring it into the second equation, and get a quadratic equation with the square root of y as the unknown. This equation is very easy to solve. By dropping the negative solution, we obtain that the square root of y is equal to 5 seconds. So y is equal to 25 over 4. Then, x is equal to 15 over 4. Thank you for watching, and see you next time.